excessive use damages to be very, very small, or at least we're being paid to take that position, needed to find every possible argument against using stated preference. That's where all this comes from. So Michael and Richard. So the obvious real attack got the name hypothetical bias. Right? You're talking to the judge. And so instead of saying, Your Honor, they could lie, you say, there's hypothetical bias in the stated preference method, Your Honor. Doesn't that sound much more convincing? And then you say, well, and then you proceed to say, and what's hypothetical hypothetical bias, doctor? I won't use their names. Oh, that's where the person doesn't have to tell the truth about what they really feel because it's just a hypothetical question. And that's hypothetical bias. There's one wonderful study. There are many studies, but one is wonderful. Rich Bishop and friends went to the Department of Game, I think it was in Wyoming, and they said, we want to find out what hunting licenses are worth, big game licenses. And everybody knew that people really wanted them because there's a lottery for them. And they get way more applications for licenses than the number of animals that they needed removed from the herd. So they knew people really wanted these things. And the Department of Game said, okay, what do you have in mind? And they said, here's what we do. You run the lottery as usual. And then we'll take a random sample of the people who won the lottery and got the permits. And we'll send them the permit and the following letter. Dear lottery winner, it's so wonderful you won the tag in this year's lottery. But we have a special offer for you. Enclosed in this envelope is a check for $300 and a return address envelope. Send us back the tag or the check. Thank you. That's not hypothetical, is it? Right. Now we know what the permits are worth because we just went and we bought them back. Same time, they do a stated preference survey. How much would you be willing to pay for a tag? The two things come out the same. So for something that wasn't politically charged, stated preference worked just fine. So that I would take as real evidence. There are other studies that people do, and generally, the stated preference, contingent valuation here, studies do not overstate what you find by other methods. I don't know what would happen if you did this in Berkeley and you pick a politically charged subject. I would think that would be the worst case. Because people are all about their politics, and I was able to tell that interviewer that those wolves are worth $10 million. Because that's what I think they're worth, even if I don't personally have $10 million. Right? So I think this might not be the right place to go asking about that. But the cases that have been done, the two numbers line up. So it's not obvious that hypothetical bias means anything. Moreover, if you do things open-ended, just stick the microphone in their face, and how much would you be willing to pay for the wolves? And you do it in a referendum format, you get very similar answers. So it's not obvious that going to the trouble of creating a referendum format to minimize the hypothetical bias advise you anything. If you're trying to say, find out if some object would sell, I don't think you would have to actually go and set it up the way we say to get the exact same answer you would get in a straight-out interview. Scope. Now remember, we're presenting this to Your Honor. Okay. So that's not hypothetical anymore, right? In the sense that you have to give up real money. It's hypothetical. No, it doesn't have to be hypothetical at all. It's, here's $100. It's too much. I can't do that in an experiment. Now it's experimental. I give you $20 and just straight out, you can allocate it to yourself or a public project, the Bailey Wolf Indemnification Fund. Yeah, it's real. Now I learned, what you would give. That's revealed preference. That's revealed preference. And you just figured out how these experiments all work. And if you listened to Lydia when she came, she explained that typically, first we give you some money for participation, and then we let you gamble in some way with the money we gave you. Where you play a game to see if you get to keep it all or something like that. Yeah, this is very typical of how this works. And there's no hypothetical. We're done. We don't have a hypothetical. You can't do experimental, though, with real money here. You can't get me as an experimental subject because $20 doesn't matter to me. It's just not real money. And by the time you pay people like me what we think of as real money, the cost of your experiment is off the charts. So we experiment on the likes of you. Or we go to developing countries where you can do experiments that involve a week's salary because you can afford to give them a week's salary and then have an experiment that involves that amount of money. So it does have some problems if you want to do experimental. But then the next thing, Your Honor, is that there's problems of scope in these things. Well, what do you mean by scope? Well, you just told us that you would pay $20 to save this lake over here. What? There are 1,000 lakes that need to be saved. So what you're doing is you're multiplying out. You're saying, but then 1,000 lakes would be worth $20,000. But that's clearly absurd. If you went to somebody and you said, I have a project to save 1,000 lakes in Minnesota, and there are plenty of lakes in Minnesota. What would you be willing to pay? The answer is not going to be $20,000. And if I ask somebody else, what would you pay to save one lake? You'll get an answer like 20 or 40 or something. So when you make the project bigger, have a bigger scope, you don't multiply by the number of lakes. But this is really crazy. So what do you really ask? You go to somebody and you say, what would you be willing to pay to clean up this nearby lake? And an example, this is from Richard Carson, by the way. But the example, in Richard's example, the person says $26. And that's incredibly reasonable. Yes, if I lived near some lake that I went to all the time, and there was a credible project to clean it up, of course I'd be happy to help clean it up because I'm the user. It's not a surprise. But then if you ask me abstractly to clean up many other such places, then I'm not going to give you a much larger answer. It's not as important to me. So why should there be the ability to just multiply by 1,000? There probably shouldn't be. And so Richard, and I'm with Richard here, we don't take it as a real criticism. There's nothing internally inconsistent there. Why not? Willing to pay less for each additional lake? Willing to pay more for things that are local? I don't see logical inconsistency. But when you go to do this, if you ask somebody about one local lake and you multiply by the number of lakes in the United States, maybe that wasn't a good thing to do. Other things you could do. You can do experiments. One of the first experiments was to see what you had to pay people to taste the bitter substance. Right? It just was one of the first things people did. And you get a number. You can do experiments with sports memorabilia. So you can have start out the way she said, give people some money, and ask them whether they say yes. If they say yes, they give up $5 and get a piece of sports memorabilia. Otherwise, they keep their $10, and you make it majority rule. Right? It's an example of an experiment. And now you can see what effect the majority has. I don't know if I'm very compelling, but could you go from that? It's an experiment. It's clean, right? I will now learn about sports memorabilia and its value in some context. But can I go from that to anything other than sports memorabilia? No, I can't. So cleanly set up experiments, they're not hypothetical. Right? I actually pay people. But now I have a problem of external validity, another big word. And what's that? It's that I've done an experiment in one place about one thing. How do I generalize from it? And a typical experiment involves a bunch of students because they're cheap. And can I generalize from that to the American population? That would be pretty dangerous. So the problem with experimental is, although you get rid of all the hypothetical stuff, it's all real, you can't necessarily learn something about a big population. Now I make a pitch for a subject that none of you would ever admit you were going to go into. How many people want to be an expert in marketing? Wow, okay, first one in decades. I think it's not crazy. And if you said this to me 20 years ago, I would have said, marketing, are you crazy? You have to wear silly clothes and create nonsensical categories like soccer moms and stuff like that. It's just utter nonsense. But today it's a very interesting field because all the stuff I've been teaching about the environment all works in marketing. You have a product, some kind of pizza that people haven't eaten before. Your guys in the lab say, trust us, the salt caramel pizza will be the big seller, right? But now you have a problem. That's what the guys in the lab think. And a few people have tasted it and they didn't die. But how do you know what will happen if you go to sell it? Do you really want to spend millions, and I mean millions of dollars, to market your salt and caramel pizza? Well, the first thing you want to do is you want to do some sort of small-scale experimentation with your pizza. So basically you want to go get a bunch of students very informally and feed them some of the pizza and feed them some of the standard pizza and see if they reach for the second slice of salt and caramel or if it's all left over. If it's all left over, you can walk away from it. But suppose, it gets some interest. Then you have to go on and you have to design a big experiment, probably in a place like Phoenix. That's where they do it, where you actually talk a supermarket, probably pay a supermarket for shelf space and put your experimental product on the shelf. And then you'll discover whether or not your small-scale work, where you have done either small-scale experimentation or hypothetical questioning or stuff like that, you find out whether or not it works. You will be marked to market. There's no way anyone's going to set up a market for wolves. I am never in danger that I'm going to estimate the value of a wolf is $17.50, and lo and behold, people go to sell wolf certificates, and it turns out I'm way wrong. Right? I'm never going to be wrong. If you go into marketing, you do exactly the same thing. If you're wrong, it's going to be obvious. Right? Thing will or will not sell. And there's more interesting marketing stuff today that I just never would have thought of. So we now have data by zip codes about all kinds of things from the American Community Survey. We can take the data that someone like Safeway collects from their Safeway Club cards. We can match that back to which zip code you came from. And we can learn what sort of things were bought by what sort of zip codes. And zip codes are homogeneous enough so that we can learn what kind of people buy what kind of things. And then we can go and hunt for other people like that to sell those things to. So for instance, suppose we find that our brand new peanut butter sells well in upper income households. Well, then I'm going to put it in my coupon books or my advertising that's going to go to zip codes that have high income and so on and so forth. So marketing becomes a very technical, geographical information systems-based field, just like ecology. So if you discover you have all these great skills and no one wants to buy them in ecology and you need to eat, maybe you should move over to marketing. It'll certainly be the strangest outcome of this class that ever happened. So that's what I have to say about valuing goods. Anything else you want on that, or do I move to a totally different subject? Going once? Going twice? All right, we're out of there. So, we did consumer theory, if you remember. Maximize utility subject budget constraint. And then we pushed it into welfare, consumer surplus, ED/CD. And then we pushed it into how do you estimate demand for environmental type goods. Now we're going on the other side. Now we're going on the supply side. And our objective is to find the supply curve and to find out what happens to supply curves as we regulate pollution. And then ultimately, what happens to markets as we regulate pollution. And we have two different types of regulation in mind. One type of regulation is sort of done by pricing, taxes, called market-based initiatives. The other side are various sorts of standards called command and control. So we're building a model of the supply side of the market, and then we're going to apply our pollution control stuff to that. What we do in the next little bit is pretty standard. We start out with the idea of an output, and that doesn't surprise you. My output down below here is one well-baked brisket. And in order to do that, I have to do something. I have some list of inputs that go into making it, and that'll give me my output. And here's my brisket. It takes a pan, 3 hours of oven services. That's too hot. I should take that down a bit. A large sheet of foil because you have to cover it. 4 coarsely sliced onions, salt, pepper, paprika, little Hungarian in our family, right? And that's a recipe. And recipe in economic jargon is simply called a technique. So a recipe to make a particular output, we would say, is a technique to make the output Q. If you want to make it short and something you can get into math speak, we just think of it as a list of the inputs, right, with the amount. So it's an n tuple, it's a vector that tells you how much of each input we use to get a particular amount of output. And here I've done it. I go down to 2 space because we can handle it. Here's one input, here's another input. Suppose both of these points make the same output. One of these points is inefficient. Which one? And why? Yeah, and why? What did it do wrong? Y is a crooked letter. Yeah, what did Y do wrong to be inefficient? Yeah, it uses more of everything the way it's written and gets the same output. So we used to have more is better for consumers, and here we have less inputs is better. So we have efficient inputs, ones that don't have, efficient techniques. And we are going to almost always, except for one exception in the whole class, but with that one exception, we only look at efficient techniques. So we can hide this in just 1 second. It'll stay hidden for quite a while. Now we have the idea of an isoquant. All of the efficient techniques that produce the same output. You had the idea of an indifference curve. What was an indifference curve? Quick definition. All the bundles a consumer would find equally pleasing. These are all the input bundles that make the same output. So the definitions are utterly parallel. Instead of it being equally pleasing or same utility, it's same output. You got an isoquant. That's a fundamental definition. So if you are writing it down, that would be, if you're doing a deck of cards, that would be one of your cards that you memorizes. Yeah, needed definition. It's also in the book if you don't love writing. I'm stopping because somebody's still writing, and I'll let him do it. Just wait a sec. Okay. Wait, what's the wrong way? No, wrong way. Efficient. Isoquant. Okay. Here is an actual here's an actual set of inputs, and here we have inputs of phosphate, inputs of nitrogen. These are all in pounds, and they're all in pounds per acre. And here are the output from the acre in terms of corn yield. So this is a set of techniques for making corn. This was done around 1953, 54. The top number on this chart is 122. Is this anything like the number of pounds of corn you get today? What happened between then and now? Well, two things happened. Two big things that influenced your world. Agriculture does matter. But GMOs is the second, right? So the idea that you could breed plants with some very interesting characteristics, or you could breed plants that were immune to Roundup or all kinds of stuff like that. But there's two real things. One of which is the seeds change with the GMOs, and that's what makes it possible to do this no-till stuff we do today. Right? And you want to be careful. I mean, you like the soil saving, but you don't like the glyphosate. So you go, I don't want to do it. Well, it's very nice. I don't want to do it. It's very nice, right? So you can waver back and forth. You're not going to be sure as an environmentalist how much you love or hate that particular piece of it. But what was before that? That's after 1950. Yeah. No, if you go back. So if you're really going back, before they fix the nitrogen, these Haber process and stuff like that, before that, they take guano and they ship the bat manure and they use that for the nitrogen. Yeah. And so they discovered it much earlier and they figured out how to do it in a more reasonable way. You're going back. But there's another piece of biology. So you're just born in the GMO world. But that's not where it started. Hybrid corn. It's conventional breeding, and they produced hybrid corn varieties that did not any longer breed true. So you had to breed them by doing a cross each and every time. But that really drove yields up quite a bit. It was hybrid corn. And at any rate, if you were to actually look at corn yield over time per acre, you would be shocked. Not only does it go up, but now it seems to have turned vertical and is going up faster than ever. Really a shocking outcome. Anyway, this is from the old days. These are much smaller than today. Can we find 2 points in here on the same isoquant? It's going from 105.4 and 105.4, right? So I got two different input bundles that produce the same output. They are on the same isoquant. That's indeed correct. Let's have another example. It's agricultural again, but not quite the same agriculture. It's rice milling. So what does rice look like when you get it off the plant, and what does it look like when you eat it? What happens in between? So I go out to a rice plant, I get the kernels off, get the things off. What have I got? Come on. Can I just boil it when I get it that way? Okay, no, what do I have to do? Peel it. What am I peeling off it? Now there's two things. So he's got the inner part. So right, brown rice has this little bit of bran on it, but that's not what comes off the plant. Before that, you have to peel off the hulls. Right? So taking rice and turning it into white rice takes some work. Next question, why do you make white rice? That might well be right. Why else? What? Yeah, for me. No, I have an intestinal disease. My intestine is smaller, and so there's just so much of that stuff I could take. Right? So I might be, for me, it's right. I could have a little brown rice, but after a while, it'd be unpleasant. Yeah, supposedly. I don't know about that. Okay. Has anyone taken rice out on a camping trip? Yeah. How long does it take to boil? White rice? How long? Or did you take the instant stuff? Did you take the instant stuff? All right, so how long does white rice take? Well, some of the other people here can tell you that in a second. How long does white rice take? 20 minutes, roughly. How long does brown rice take? An hour, 40 minutes. Okay, so out on your camping trip, am I going to get you to take the brown rice? No way, right? I'm not carrying an extra can of gas so that I can have brown rice. I'm not going to build my fire twice as big so I can have brown rice. Okay, let's take this to a developing country. Is fuel cheap or expensive? It's expensive, right? If you go to something like Ethiopia, I think it was